Boiling and melting points. Boiling point is the temperature at which a liquid is at the equilibrium with the gaseous state and when its vapor pressure equals to the atmospheric pressure, whereas melting point is the temperature at which a solid substance is at the equilibrium with its liquid at constant pressure. In general, the stronger the bond between the atoms of an element, the higher the energy requirement in breaking that bond. So melting point and boiling point of the elements depend on the number one, strength of the bonds within the molecules, structure of the molecules itself, whether it is ionic molecules or covalent molecules, and also the forces acting between the molecules. In general, metals possess a high melting point, whereas the non-metals, most of them possess low melting points. The non-metal carbon, however, possesses the highest boiling point of all the elements. The semi-metal boron also possesses a high melting point. As the boiling points and melting points depend on the type of bonding, we need to know about the bond elements in the periodic table have. For metals, it is the metallic bonding. Metallic bonding is a strong force of electromagnetic attraction between electrons that move freely or being delocalized. Sometimes it is described as an array of positive ions in a sea of electrons. The red dots indicates the delocalized electrons. Let's discuss about melting and boiling points of group 1 elements, the alkali metals. Going down the group, as you can see from lithium to cesium, the melting point decreases, so as the boiling point. So to understand why this trend happens, you have to consider the metal structure or the bond that makes up the metal structure. So for metals, it has a metallic bond which consists of positive ions or cations being glued up together, hold up together with a sea of electron. So for these alkali metals is in group 1, so each of these atom release one electron of their valence electron to contribute to this sea of electron. So in order to melt this metal, you have to break the attraction forces or the bonding exists between the positive charge and also the negative charge of the electron. That's why lithium is the hardest to break because it is a small size, so the attraction between positive charge and the negative charge of the electron is higher compared to ones in cesium atom, which is larger. Therefore, the positive charge and the negative charge of the electrons are further away. That's why it is easier to break the bond in cesium. Hence, the metallic bonds are weaker going down the group, and therefore the melting point also decreases. The same trend and reason for why the boiling point of the alkali metals decreases going down the group. Let's discuss about melting and boiling points of group 17 elements, the halogens. This table shows the elements and their physical state at room temperature with their boiling point, melting point in degrees Celsius, and also their atomic mass. So fluorine exists as a light green yellow gas at room temperature, whereas chlorine exists as a green gas at room temperature. But bromine is a dark red-brown liquid, whereas iodine is a steel gray solid sublimes to a violet vapor when it vaporizes. So you can see that the melting and boiling point increases going down the group. Is unlike the group 1 of alkali metals. Going down the group, the melting and boiling point of halogens increases with the increase of their atomic masses. This is a melting point of halogen group in units of Kelvin. So you can clearly see the increase from 85 to 610. This is correlates with the increase in atomic mass of the halogens. Okay, so for group 17 and group 18, the boiling point and melting point increases due to that the halogens are diatomic molecules, so they exist in this form, so F2 Cl2 Br2 and so on. So as the molecules gets bigger with the increase of atomic masses, there are more electrons that can cause more influential or increase in the van der Waals forces that binds the F with another F atom that forms the molecules, and same goes with the chlorine. So these forces that binds the atoms together in a molecules, you have to break these van der Waals bonds, van der Waals forces to melt this halogen. So the stronger the forces, the more energy you need to break the bond, which results in higher melting point or higher boiling point. So in the case of halogens, the melting and boiling points depends on the atomic mass of the elements.